All right, 7.3 is applications, real life use of growth, decay, and compound interest. So growth and decay, as you can see here, have very similar formulas. Okay, the only difference is one's plus and one's minus, which makes sense. Plus is growing, minus is decaying, decreasing. All right, so all the letters are there. You can read on your own. Just going to dive right into the problems. All right, the value of a sports car purchased for $45,000 decreases by 15% each year. Write an exponential function to show the value of the sports car. All right, so again, we have A, which is the future value, equals A sub O is the starting amount. So that's your $45,000. Now, since it's decaying, decreasing, we're going to use the 1 minus R. What's the rate? 15%. But we don't put it in as 15%. We move the decimal 2 places to the left, 0.15. And then T is each year. Okay? So that is the formula you would use. All right? What is the decay factor? That is this 1 minus R, the decay factor. So 1 minus 0.15 is 0.85. Find the value after 5 years. We're going to take this 5 and plug it in right here. So we're just going to write this again. The future value is 45,000 times 0.85 raised to the power of 5. Now when I do this on the calculator, I do it kind of backwards. So I do 0.85 to the power of 5. And then that times the $45,000. And then since it's money, we're going to round to the nearest cent, which is that 73 cents. But the 9 tells you to round up. So it's going to be 19,966 and 74 cents. So in 5 years, it goes from 45,000 to being only worth about just under 20,000. All right, 2010, population of a small town is 15,000. It's been growing by 5, which means plus. We're going to move this twice. That's 0.057. Kind of helps right above there, just to remind yourself. Write the function. So the formula is future value, starting amount, 1 plus 0.057 to the t. What's the growth factor? That's this. So it's 1.057. What will it be in the year 2030? Well, it started in 2010. So we're going to take 2030 minus 2010 and get 20 years. And that's the number that's going in for time. So again, future value, 15,000 starting amount times 1.057 to the power of 20. So 1.057 to the power of 20 times 15,000. Again, we're going to round to the nearest penny. So 97 cents, but the 7 is going to round it up, so 98. So 45, 45, 5, and 98 cents. Whoops, sorry, this is not a money one. Now, when we're talking about people, we're not rounding to money. We're actually going to round. Now, here's the thing. We actually don't have enough to make that. Whoops, that was an accident. We don't have enough to make this whole number of people. We have 0.98. So actually, it's 45,455 people. Now, again, normally we would say, well, 98, that clearly rounds up to 456 people. But in real life, we don't have that whole person. We're really close, but not that whole person. So technically, it's going to be 455, not 456. Very common mistake. Look out for that one. Whenever we're talking about like animals or people, The rounding rules are a little bit different. All right. Federal income tax returns. Self-employed employees can depreciate, that means minus, the value of business equipment. Suppose a computer originally started off being this much and it depreciates, again, minus, at a rate of 30%. That's 0.3. Write the function. Future value, starting value, 1 minus 0.3 to the power of time. The decay factor is 0.7. 1 minus 0.3 is 0.7. And we're going to do this in 3 years. So future value is 2675.7 to the power of 3. So 0.7 to the third power times 2675. 917.53. The 5 tells the 2 to round up. So 917.53. Because it is money. All right, a certain stock opens up with this price. Over the first 3 days, the value increases, that's plus, by 50% per day. Now notice, these have to match. All right? Pay attention if there's days and weeks, you might have to convert, but this is days and days. So, future value is the initial amount, the initial price, 0.59, 59 cents, 1 plus 50%, which is 0.5, to the power of time. Okay, we're talking about 3 days. That's going to go right here. I'm sorry, my bad. Over the first 3 days, it increased 50%. So that's the amount we're using. We're going to use 8 for this. So the growth factor is 1.5. And we're going to say here, A equals 0.59 times 1.5 to the power of 8. Hold on, was not using my brain. This was after the first 3 days. We're talking about 8 days total. That means there's 5 days left. So we're not going to put an 8 in there. This is going to be 8 minus the 3. This is going to be 5. Kind of a sneaky one. In fact, I wasn't even paying attention at first myself. So 1.5 to the power of 5 times 59 cents. So $4.48. All right, now here's an equation that's already given it to you. Okay, we have all the information. So this is the future value, starting value, amount of time, and this is the factor. Remember, it's 1 minus something equals 0.85. So what is that? Something that was taken away to equal 0.85? 0.15. And really the way to do that is just algebra. Subtract 1, then divide by -1. Because if you subtract 1, you get negative 0.15. Divide by -1, you get 0.15. So how many years? 6. The annual percentage of depreciation is 0.15. Be careful. Again, it's not 0.85. That's the factor after you subtracted the 15%. Initial amount, $7,500. Use the equation right here to determine the annual percentage of appreciation. Okay, so again, future value, starting amount, time, this is the factor which is 1 plus something equals 0.15. Sorry, 1 plus something equals 1.15. So again, simple algebra, subtract 1, and you find out that it is 0.15 or 15%. That was the amount of appreciation. Appreciation is easy because it's just whatever follows the 1. All right, that's pretty easy. It's the subtraction one you got to be careful with. All right, compound interest. Compound interest is more advanced. You make money on previous money. That's why instead of just being 1 plus R here, notice we have this extra N here and the extra N there. And there is no 1 minus because this is a way to make money for you or the bank. A few things to remember here. Annually means once, semi means twice, quarterly 4, monthly 12, weekly there's 52 weeks, and daily there's 365 days in a year, but banks use 360. Why? It's to their advantage. So that's what they use in business is 360 days. How are these problems different than regular growth decay? The compounding. So you make money on money. So you want to invest $5,000 in an account that pays 3.5% interest that's compounded semi-annually. So remember, this is 0.035, and this means twice. So that would be future value, $5,000. 1 plus always, the rate on top, 0.035, N. Okay, so remember, look up here. N is the number of times it's compounded. That's this number right here. So that's going to be 2. And then a 2 here, and then T for time. How much for 5 years? We're going to plug that in right here. So A equals 5,000. 1 plus 0.035 over 2, 2 times 5. Or you can just write 10. Now, personally, when I do this, I take baby steps. So I start with the 0.035 divided by 2. Then I add it to the 1. And then I take it to the power of 2 times 5, which is 10. Now, if you know in your head, you can just type 10, or you can literally type in 2 times 5. It'll do the math for you. And then take that times the 5,000. So again, here I'm going to round. It's going to stay down at 22 because I have 222. So 59.47 and 22 cents. How much would you have if it were compounded monthly? The only difference is my N changes. So 1 plus 0.035 over 12, and then this is going to be 12 times 5. So that's going to be 60. So again, 0.035 divided by 2 plus 1 raised to the power of 12 times 5, or 60, times 5,000. All right, this is a correction break in the notes. Hopefully you just noticed as I was saying that and typing the calculator that on that problem, I divided by 2, when obviously the problem should have been divided by 12. So the answer you're going to see here in a few seconds is somewhere in the 14,000 range, but the actual answer should be 5,954.71 cents. So hopefully you noticed that when I was doing the video, as I did not match what I said I was typing in. So this is the actual answer. So no 081, so that's 8 cents. So 14,159 and 8 cents. So quite a bit more. Just changing the compounding value. All right. Fred has been saving money for birthdays and other events since he was born. On his 16th birthday, he took all $3,800 from his piggy bank and put into an account earning 5.2 weekly. So that's 52. This is 0.052. Okay. Now, on his 16th birthday, that's a distractor. That's just when he took it out. So, future value is based on the 3,800 initial, 1 plus 0.052 divided by 52 raised to the 52 times t. Now we're going to plug a 4 in there. So future value is $3,800 times 1 plus 0.052 divided by 52, and then 52 times 4. Which again, the calculator will just let us put that right in. So 0.052 divided by 52 plus 1 raised to the power of 52 times 4. And then that times 3,800. So rounding, 1, 2, 3, the 3 tells the 2 to stay. So 46, 78, 12. 46, 78, and 12 cents. All right. Mary plans to put her graduation money into an account and leave it there during college. She receives $2,000. That's my starting value. 4.05, move the decimal 2 places. So 0.0405 quarterly. That's 4 times. So future value, initial amount, 1 plus 0.0405 divided by 4, 4t. After 5 years, how much will she have? Well, let's see. $2,000. 1 plus 0.0405 divided by 4 to the 4 times 5, or 20. So 0.0405 divided by 4 plus 1 raised to the power of 20, or 4 times 5, times 2,000. 24, 46, 43. The 7 rounds the 2 up. 24, 46, 43. 24, 46, 43. How much will she hit if she waits 10 years? How much would she have? And how much money did she make off the investment, being patient? So we're going to change this 5 to 10. So we're going to do the same amount, 1 plus, same interest rate. Okay, it's still going to be quarterly. Still going to be quarterly, but this is going to change to 10. So 0.0405 divided by 4 plus 1 raised to the power of, this time 4 times 10 is 40. Times 2,000. So 29.92 and 50. The 4 tells it to round down. 29.92, 50. How much did she make off this initial investment? We just subtract 2,000. That means she made $992.50 as opposed to $446.43. So almost double for double the time as it works out. Identify the important information. The initial investment is the $3,000. The rate is 0.045, which as a rate is 4.5%. Number of periods, that's the repeat number. So that's 12, which is monthly. Time of investment, that's the other number up top, 4 years. And that's it.